Lecture 23rd A. Riemann curvature. Now, abstract definition. Why abstract definition? Because our goal is to compare the abstract definition with the formal definition, okay, as we derived previously. Now, is this abstract definition is more common, okay, to use, okay? That's exactly analogous to what we did, similarly what we did with the torsion, okay? We defined the torsion and then the abstract definition of torsion. So, consider the abstract definition of the Riemann curvature tensor as an operator acting on a vector field. You see, this is R hash x, y, z. This is abstract definition. This corresponds to the second derivative. You see, this one minus this covariant of z, now x and y. You see, that's a bracket. Our goal is to compare with the definition of the 1,3 Riemann tensor derived in lecture 22. Now, let's start with the abstract definition expressed in local coordinates. You see, let partial of xi be a covariant basis, and x xi partial of xi, y is yj partial xj, and z zk a partial xk. So this belongs to the vector space. Now, recall that 1. You see, the covariant derivative of this derivative of xi, this derivative of xj, by definition, is the Christoffel symbols, okay? Gamma k ij partial of xk. That's the definition. And number 2, this covariant derivative of y, okay? This is capital X. This is xi, okay, yj partial xi, this the vector x expressed in coordinates, okay, the amplitude xi, likewise yj. Then that's a very important property what we derived, the property of covariant derivative. You see, xi is a scalar, okay? Coordinates are function. This is a scalar. So the properties, okay, this scalar here moves to here. You see, that's a property of the covariant derivative. Then I repeat xi, now covariant derivative of yj partial xj. You see, this we use the product rule, the Riemann's rule, okay? So that's a very important properties of the covariant derivative we derived previously in previous lectures. Now, first term, you see this color here, okay? This is in this case over here, there's a green one, that's a green one, okay? Today is 11, okay? Now, the first term over here, so the green one. Now I will expand just the blue one. The blue one is this one. What I denote, this case, capital W, okay? This is, you see, WK, these are components of this vector, okay? This is a component of this vector. This is a vector field, you see? So this is yj, okay? Then I already derived, okay, the covariant derivative over here, and this one, you see, there is here no partial respect xk, because I'm just working with the components. You see, so this is what we did for the covariant derivative. You see, this is the Christoffel symbols, okay? Just appear when I use this relation over here. You see? Then then that I again here, you see I derive this one. You see this, there is a partial xk, okay? Now this xi over here, this is you see that's this case that I derive this. Attention now, this is partial xk, this is partial xl, okay? I just set here, okay? In this case, you see this case here, I can substitute L because L is dummy, okay? By K, then this will be leads to partial xk. You see what I mean? L here, okay, is dummy, okay? I can substitute over there. Then clearly we can derive this covariant derivative of W, which W is partial, in this case, covariant derivative of Y or Z. This I said before, this corresponds to the second derivative. You see, that's, you can see clearly here, you see the second derivative. This act on this act, in this case, on the other one, this means the second derivative. So this term here, okay, I will continue this term here on lecture 23b, okay? The second term, okay, I just swap, you see, y, x and y. You see here, swapping x and y and I and j. Then I move from here to here. That's a straightforward. So that just substitute, okay, what I swapping. xi, x with I and I with j. I copy and let here. Now I will continue on lecture 23b, okay? Then I will use, okay, I will expand in more detail this expression here and here, and also you see using the Lie derivative here. This pumpkin orange color here I use on lecture 23b. Okay, that's it. Remember, our goal is to compare the abstract definition, okay, with the formal definition of Riemann curvature. Exactly what it did for torsion. That's our goal.